Okay, so now we're going to talk about increasing, decreasing, and constant parts of functions. So for increasing functions, this is our formal definition. It's telling you if you have two x values that are consecutive to one another, in order for a function to be increasing, the output for the first x value has to be smaller than the output for the second value. Okay? For decreasing functions, it's just the opposite. We have two consecutive x values. Our first output for the x value is going to be larger than the second output. So that's going to be our decreasing values. And it's very easy. You have two x values on some kind of open interval. If their outputs are exactly the same, that means that nothing is changing and it's going to be a constant function. So let's flip the page and we're going to do an example. Or two or three. So we're going to determine on these intervals which parts of the functions are going to be increasing, decreasing, or constant. So if we're looking at this first function here, f of x equals x cubed, if I look, it looks like every single time that I'm moving over, my output is just getting larger and larger and larger and larger and larger. So I'm starting from negative outputs, large negative outputs, and going all the way up close to 0, and then it's starting to become a large output for our positives. So in this case, we only have an increasing interval, and it goes from negative infinity to infinity. The second example here, f of x equals x cubed minus 3x. So it's really nice. They're giving us two coordinates. It looks like it's at the peak and at the pit over here. So if I'm starting all the way from the left, it looks like I'm increasing all the way up here up to that coordinate -1, -2. Then it looks like my outputs are getting smaller and smaller and smaller and smaller as I go from left to right. And then again, that changes to becoming increasing outputs here. So for this second example, we have two intervals on which it will be increasing. It is going to increase from negative infinity all the way up through to that peak there, which happened at the x value -1. And I'm not including -1 because something else is happening at x equals -1. Okay. It's also increasing from this coordinate 1, 2, -2 all the way up through infinity. So it's at 1, infinity. Again, I'm taking the x value of that little pit there, and it's not going to be a hard bracket here because there are two things happening at this coordinate. It's decreasing and it's increasing. So we happen to have a decreasing interval, and that is occurring between these two, the peak and the pit. Okay? It's happening at between x value of -1, and it's decreasing all the way through the x value of +1. Okay. Now we have a piecewise function here for our third example, and we have all these restrictions for the x values here, and we're going to really pay attention to the signs that we have, the greater than or equal to, less than or equal to, all these fun things here, and just the less than. So let's talk about our increasing interval. That is occurring between, well, if I'm starting from the left, it's starting at negative infinity when x is negative infinity, and it's increasing all the way up to this point right here, 0, 1. So it will be from negative infinity through the x value 0. Let's talk about decreasing. Okay, and this is decreasing from, well, it looks like to me, this point 2, 1, that's where it starts decreasing on the function. So the x value of that point right there is 2, and it's going all the way through to infinity. Now this one does have a spot where we're staying constant. Okay. And you can see right here it's just a flat line, a horizontal line, and that's occurring between the x value of 0 and the x value of 2. But if we look here at this piecewise function, it tells us that the value of 1 is going to be our output when 0 is less than or equal to x, and that's less than or equal to 2. So because this has the or equal to portion of it, you are going to be able to put your hard brackets here between 0 and 2 inclusive.